Yes,
Hello,
we are live.
guys. Yeah, cool. Hello, everyone. Hello to the Sherlock and the Zivoe code walkthrough. Basically, my name is Artemi. I'm from Sherlock team. Also, we have Forja here and the John from the Zivoe team. So, really excited to have everyone here. Today, we will have a code walkthrough for the our Zivoe contest that we have that started today, basically. And yeah, I think we can wait a couple minutes for everyone to join. And after that, we will start. So, some technical moments, basically. You can ask your questions in the chat on Twitter or on YouTube. You can ask your questions during the session, and also we will have a Q&A session after the code walkthrough, the main part. Um, Yep. And also, hello to everyone who is watching us on the recording. So, yeah, I hope that it will be super helpful for every Watsons who wanted to participate in the Zyber contest. Um,
Good morning, good afternoon, good evening, wherever you are around the world. I have to imagine there's some Watsons spread out around the world.
yeah, yeah, definitely. Okay, yeah, I think that we can wait for like a minute or two, and then I'll pass the mic to the John from the Zyber team, and he will start.
Yeah, we've got a few already watching from Twitter.
Hey, guys.
Yeah, just let me know when you
And
guys are
YouTube.
ready, and I can kind of dive in.
Okay, we're past 50 in both Twitter and YouTube, so I think we can get started.
Yeah, sounds great. I also see the first questions in the chat. So, yeah, uh, thanks everyone to joining. John, I'll let the mic to John from the Zyber team, and we'll start our code walkthrough for the Zyber contest.
Yeah, perfect. And I see the comments off to the side here too. We've got one from Biased about the
Yeah,
docs. I'll read that in a second. Yeah, so let me just start out. Artemi Forja, thanks for having me and setting up this live code walkthrough of Zivoe. I'm John, the head of technology, architected a large portion of this protocol and implemented it. Obviously have a large team, a very solid team to help me as well. Um, and my goal really today is to create a fairly high level walkthrough of the protocol so that the auditors, the Watsons, can start here and start with this and make it just much more streamlined and easier to understand the code base, what's going on, where they can find the files, what's in scope, what's not in scope, and some other interesting aspects to our code base that is going to be important just to get your hands on it and start working with it. Uh, and some things that I thought about when I was architecting it, and also what's important to perhaps focus on, some areas that we may think are worth just directing attention to because it could be more critical than other parts of the code. So that's at a very high level. It's a kind of the scope for today. And let's see, let me just look real quick here. The docs state that governance will be able to add new underwriters, but I do not see any functions related to this in the Zivoe visualization graph. Is this still an intended feature of governance? Um, I'll answer that question. So basically, we've got the ability to add new lockers, which are just contracts that manage the lending, and those can have new underwriters when they're deployed. And we have a whitelist of like lending lockers, and that's I'm going to get to the architecture of that and how that works a little bit down the line. But the answer is yes, you can do that. GMs to everybody else. So let me start by actually, I think I'll start by sharing my screen. I want to just give all the resources that are available and what we've got online. Open it up here. Okay. All right, does that look good? Everybody can kind of see what I'm showing?
Looks good, looks good.
Awesome. So the three main repositories that we've got are Zivoe Core Foundry, which has the source code for, actually, let me go back here, all of our smart contracts. We have previously been audited by runtime verification, not the exact version that's currently on the master branch, but I would say perhaps about 15 PRs or 10 PRs ago, we had the, but there haven't been too many changes since. But if you'd like to look at the report from the runtime verification, you can look at the report. We have the core report and we have the lockers, because we kind of break down our protocol into two main sections. And this is here. And actually, I want to take a step back real quick, because I just realized I should kind of explain what Zivoe is at a very high level. That would be rather important, because there's these one-liners like, okay, Zivoe, it's an RWA decentralized credit protocol aiming to disrupt predatory high-interest consumer lending globally, initially in the US, a huge focus in the US. But what is it really? I mean, what is it akin to, if you're familiar with other protocols in Ethereum? And I would say you could think of it like other credit protocols, like Maple or Goldfinch, but instead of having different pools that you can kind of select what you want to have exposure to, you can think of Zivoe almost as a credit ETF, where you have three main tokens in the system. You've got the main ZVE token, but then you have these two tranches. And all of the yield from all of the sources, you could have loans out here, you could have, even yield from certain things on chain here, but primarily we're focused on, lending. All of the different yield sources kind of come together and then flow into these different tranche tokens and the ZVE tokens. So at a very high level, it's I would think of it as like, blended exposure of everything that's going on, and without going into the reasons why we're doing that in detail. I mean, it's a little more diversified, lower risk, and more value to the token in that regard, once we get into the kind of the tokenomics and how all that's set up. And then I'll kind of explain how that is accomplished, how this like credit ETF structure is accomplished via the architecture of the protocol. So we've got three main repositories. We've got, and actually, let me just check real quick. No questions. All right, we're good. Hopefully I haven't lost anyone yet. So we've got three main repositories: Zivoe Core Foundry, all of our smart contracts in the source repository or the source folder here. We do have a link to the docs here if you'd like to read them. Although personally, I prefer reading NatSpec, and perhaps, as I explain in this code walkthrough, I think I can do a better job than the docs, but the docs are very good. The structure of this repository is kind of as follows. We've got our core contracts and brief descriptions for every single contract, and then within the source directory, we have a libraries folder and a lockers folder, and some miscellaneous. So I'll kind of just walk through the scaffolding of this directory real quick. So in our source directory, we have all of our contracts that we would consider core here. at the top level. And anything we would consider non-core would be in the lockers. And we have this broken down into different folders based on the nature of the locker. And then libraries, we have miscellaneous kind of helper contracts that don't really fit in anywhere, but we just have them. They're vital. We need them, but we've just put them here. Maybe they're reused multiple times, necessarily kind of like a library would be. And then miscellaneous, we don't actually have anything here. We just kind of threw contracts that we were using, but this is out of scope. So libraries and lockers are in scope. There's one directory within the lockers that I think is out of scope, but that's about it. So on top of that, I'm going to go through the other two repositories, and then I'm going to kind of just give a brief breakdown of like kind of from a protocol architecture standpoint, how things work. On top of that, we have the Zivoe core testing repository. Foundry RS based, so all of our unit tests and fuzz tests are based in Foundry. There are instructions how to set this up here. So you would need to clone it. You would need to run this command, git submodule update --init --recursive, because we do have in our lib folder here a submodule for the Zivoe core Foundry. And running that command will allow you to then have the Zivoe core Foundry repository as a submodule initialized within this this repository, and it'll look something a little bit like this. So you can kind of have your Zivoe core testing repo pulled up, and then you can run your, it'll look like this, forge test, and I'm totally revealing my inferior RPC URL. Can't do anything about that. But this will be how you would actually run the particular tests. And, as I'm sure you can use regex when you do match tests to run a particular series of tests. I mean, we kind of did some pretty good naming conventions. Like if, we've got the test for all the core contracts under core, lockers, we have everything kind of there. And then if you go into one, you have like the actual name kind of prepended that matches the name of the actual file. So if you just wanted to run all of the OCC modular files, you can just do that, and that would run all the OCC modular files. So that's kind of nice and convenient. And finally, let me just think, is there anything else I kind of want to touch on in this? I will come back to this because I do want to explain actually how this utility.sol file is used. I think I might come back to that next, but I'm going to go to the next repository and just explain that briefly. So we do have sort of this Zivoe MEV mitigation helper repository. You can ignore the description here. We forked it from this Flashbots, Web3 Flashbots repo, and what we're intending to do is use this for MEV mitigation purposes to fire transactions on, Flashbots RPC URLs. But primarily what this is here for, and why I'm explaining this, is because we have a Zivoe folder here. And within this Zivoe folder, we have a 1-inch API file, and then we have another file which kind of uses it. And this is for testing purposes. And what I mean by that is, look at that, all those tests are passing, how nice. You kind of see here, if you were to run forge test on our just the whole test case repository, you're going to notice that a lot of these are failing related to Zivoe Swapper, OCY, OCT, yes. And the Zivoe YDL, there's actually these tests in here which should not be failing. I think I have a mismatch on the PR that I'm working with, but this should have been resolved, so I need to look at that. But in regards to the Zivoe swapper OCY issues, within our code base, we have this contract. It's called Zivoe swapper. It's under lockers utility. And this actually integrates with 1-inch V5. And the 1-inch V5 implementation here allows us to supply data that we get from the API of the 1-inch into a smart contract, and it will execute that transaction. It's like the most efficient swap for maybe, say, like if we look at a particular test case. Let's say OCY OUSD. And OUSD is a stablecoin, by the way. And we need to, in our scenario that we're testing, to test, hey, we're converting USDC to OUSD, 200,000. What is the 1-inch V5 data that we would supply to do that? And that's where we have to actually regenerate data, because if you think about it, if we're trying to really test this in live or simulate it in live through RPCs, we need to use swap data for the current state of all of the pools that 1-inch is saying, hey, this is how you would swap it. And so what you can do is, we've got like OUSD, or let's say it's USDC to OUSD, and it's 200,000. And this is pulling from just some JSON data that we've got here for the stablecoins and the assets. Then we can just run this, and this is actually just using this 1-inch library to hit their APIs and get the most recent data for doing a 200,000 USDC swap to OUSD. And then you can copy this data into here, and then you have to actually, take out the OX and use the hex specification for this bytes string that we're providing to data swap. So that's actually how you would do this, and that's why I'm talking about this Zivoe MEV mitigation. And this is what we would actually, we wouldn't do that in live. We would have a specific, slightly different way, but so that's kind of a breakdown of the 3 repositories that you're going to need for this particular audit. So let me take a break there and just kind of, before I go too down the rabbit hole, there's a little bit down the rabbit hole, but very important. Was the code base forked or based on an already existing project, or is it all custom written from scratch? It's all custom written from scratch. Are tests in scope because they are listed in the scope page? I'm not, okay, so in terms of auditing, we don't need audits on the tests. I think that it was asked for us to just mark which test cases were relevant to the protocol that you would run. Now, when I run, this just generic all the tests, it is the ones I will say that are not relevant are really at the end here. Pre-sale, ZVT, error, test validation. Don't worry about these. But the OCY, OCT, Zivoe swapper, and Zivoe YDL, everything else is in scope. So that's kind of how you would get your hands on these test cases and start running it. Let me just kind of undo that. Let me now kind of like take a step back at a higher level and just explain what the contracts are generically, and then things to keep in mind, how they're intended to work. So I'm just going to kind of go through what the core smart contracts are and some things to keep in mind, some additional resources we have here, which is a Figma. And I see here that we've actually already got about 12 people on this Figma. It's pretty awesome. There's 5 kind of phases, although I would say phase 3.
Sorry, John, I think there's a problem with your microphone.
Oh, is there? Oh, wait. Hold on.
Okay, now I can hear you well. We can hear you well now.
Okay, you can hear me?
No,
Oh,
it's fine.
wait, I see we've got some acoustic ambient. Wait, maybe I should leave that playing. I don't know if this plays for other people or just for me. That's hilarious.
I think it's just for you.
Oh,
But
okay,
either
very
way,
nice.
it's fine now, and I'll let you continue.
Okay, you can hear me? All right, thanks. Thanks for pointing that out. So this is a really great Figma document. There's 5 phases, although I would say that we have a phase 0, by the way. I would say that phase 3 and phase 4, you can kind of think of them the same. But again, I think it's really helpful. And as I go through this over the next 5 to 10 minutes, I think to understand how we have a delineation between core and non-core smart contracts. So over here, we've got phase 0. This is really when we're deploying the protocol. All right, I got to turn this acoustic ambient off. And the deployer, we have kind of these triangles. So these dark green squares are contracts, and these diamonds, lighter color, are roles within the system. And the endpoints here, the text between the lines that are connecting them, are the functions that they're intended to call. So the deployer initially is naturally just kind of calling the constructor and deploying all of these contracts that we see here. And we do have a setup phase. So you'll kind of see here the deployer is responsible for making all of these calls to these different contracts. This isn't in any particular order, by the way. I think this might just be, there's no particular order here. We have the deployer handling most of these things, and then we also have ZVL as another role. So in our Zivoe core testing repository, in the utility folder, there is a utility.sol contract. And in pretty much every case, if you're every test file, if you're familiar with Foundry, we have the setup function, which is run before every test case, and primarily every single one will call deploy core false, and that is pulling from the utility. So all of our test cases are is utility, and this deploy core function is coming from the utility contract, and we have a Boolean input live. So we would actually use this when we're in production to test, hey, did we launch everything, and is this meeting our particular test deploy core? But for simulating it for the purposes of this audit, we always supply false. And this deploy core is effectively simulating the deployment of this protocol to the network. And I think it's kind of important to I'm just going to go kind of, there's steps lined out and just kind of cross-reference what we have on the Figma with what's kind of going on here. So the first 2 things, we have the create actors, and then we have the setup tokens. So Foundry is really awesome in the sense that we can actually initialize a bunch of actors that we can have try functions for. So this create actors just kind of creates all of these, we've got admins, black hats, borrowers, deployers, managers, investors, and investors. And then we've also got, if I go back to deploy core, we have setup tokens. So setup tokens is just a way to actually initialize the tokens on the mainnet so that we can use something really nice. It's an endpoint called deal with Foundry RS to effectively simulate giving a particular amount of, like say we want DAI or USDC to a given address for a given amount. We have to specify the specific address and the slot, and then that allows us to use this deal endpoints. This is great for simulating. Like if we wanted a billion USDC, right, we could simulate that. Let's go back to deploy core and actually start talking about what we're doing. So the actual deployment starts with deploying Zivoe globals. And Zivoe globals is this contract that basically houses all of the these other endpoints, these other addresses for the contracts in the system, and also manages a whitelist of keepers, of lockers, and of stablecoins. The important thing is pretty much all of these addresses are like contracts, except for ZVL. And ZVL is meant to be like an administrator to handle just critical functions of the system. But pretty much what happens is this globals is launched first and foremost, and then we effectively will launch every other contract here, and then we will go back to globals, and then we'll run this function called initialize globals, which pretty much provides and locks these values in. They're static once they've been assigned, and this automatically will then we just actually, it doesn't automatically renounce ownership, but then we renounce ownership right after that. So that's the initial setup and purpose of Zivoe globals, because every other contract in the constructor, you'll notice, pretty much has a reference to the Zivoe globals contract. And what happens is we deploy globals, and then we deploy everything else with the address of globals and all the other contracts, and we use that as a reference, a hook for everything. Like that. So let me just stop there. We'll just see what we've got. Figma URL, can you share the visualization slide? Yeah, we should have the visualization slide in the as a URL, but if not, in our scope that we've written for the context, the Q&A for the Sherlock information. But if not, or if you can't find it, I mean, feel free to ping on Discord. We will definitely send that over. When an underwriter is creating the loan off-chain, what is the expected grace period and number of terms for loans? When the underwriter is creating the loan off-chain, all of the terms are on-chain. I believe, let me look at that again in the OCC. We're going to get to the lockers here shortly. But the terms would be subject to change dependent upon, like, what are the current market conditions and what's the current agreement and the risk profile. But I believe the expected grace period is set. I think it's defined at 14 or 28 days, but there is code for that, so I'd have to check. I don't remember off the top of my head. Okay, so kind of coming back here, so we see Zivoe globals is the start, and then we deploy everything else, like the Zivoe token, our governance contract, the time lock controller. We kind of specify an executor role, proposal role, canceller, time lock admin role. This is actually revoking it. Deploy the DAO, and we have an initial setup, an initial distribution that we want for the ZVE tokens when we begin. So keep in mind, J here is actually the deployer in the initial setup, and there is supposed to be a specific way that the protocol is set up, like the order it's set up, a couple of settings, where the ZVE tokens go, and so we can think of the deployer as a role, and again, they can do anything that they want, but if it wasn't set up as the way it's supposed to be, then that would have to be, undone. And we have a set, like after everything's done, this is how it's supposed to be to validate that for production purposes. But this kind of shows what we would expect it to do, and it simulates that going into all of our other test cases. So then we deploy our senior and junior tranche with the Zivoe tranche token. Then we deploy the Zivoe ITO. We actually give minting privileges to the ITO because there are only, for the tranche tokens, these are mintable tokens, which have minter roles, and we want to only give the minter roles to the ITO contract, and you'll see here right below to the tranches contract. These are the only two contracts that should be allowed to mint the tranches, and then immediately after that, you can kind of see here, we renounce the ownership of these contracts, and then I believe we renounce ownership of the actual two tranche token contracts as well, so that the minter roles beyond the ITO and the Zivoe tranches, there is no possible way to mint these tokens or change the minting role of the tranche tokens beyond that. Then we have staking contracts through Zivoe rewards that we deploy for each particular token. Then we have the YDL. The YDL is a very large contract filled with some fairly interesting mathematics. I think it's worth explaining how the YDL works because it's probably the least straightforward contract and it's not immediately clear what's trying to be done. So I'm going to actually take a moment to explain that, but I'll finish explaining this utility, this deploy core setup function. So deploy the Zivoe YDL, we actually have a helper function called Zivoe math, which we then deploy for the YDL. Actually, sorry, in the constructor, we actually deploy that within the YDL for that. And we just happen to reference it here so we know, because it's like a separate contract, but it's, we just needed to have a reference here. Then we have a vesting contract. So we have two kind of Zivoe rewards contracts. Zivoe rewards, which is just separate. It's just, you just stake your tokens into that. It can be ZVE, Zivoe senior tranche token, or Zivoe junior tranche token. Then we have this Zivoe rewards vesting contract, which works exactly like the Zivoe rewards, these staking contracts, except this is where a large portion of ZVE will go and is vested out to the team, to investors, to future team members, future investors. And you cannot stake directly to it, but it handles vesting schedules and allows you to have, kind of, it's almost as if you are staked, but you cannot unstake them based on a certain amount, which increases linearly over time to the vesting schedule. So that's the purpose of Zivoe rewards vesting. And then here at the very end, we transfer some into the vest CVE, majority of the ZVE tokens, and then we've got, finally, once all of the contracts of the protocol have been deployed, we store them here into a fairly long array of addresses, and we call the initialize globals function in Zivoe globals and renounce ownership there. And that kind of does it for the core setup, although for the, there's two final things that we have to do, which is for the Zivoe rewards contracts, we need to specify that, sorry, I've got all these pop-ups. Visual Studio Code keeps kind of, all right, so we have to add the rewards for each of the different staking contracts. We have DAI and ZVE, and then there's a specific amount of time, which is 30 days, for these to kind of release when rewards are deposited. And I think it's worth explaining, and I'll also touch on how the Zivoe rewards contracts and staking contracts should work at a high level as well. But then, yeah, then there's one for the VEST CVE. Then we kind of update the lockers, and that's it for the setup. So this is pretty much phase 0. And then phase 1 is kind of like launching all of the lockers. So this kind of brings me to, and before I do that, let me just see if there's any other questions. Nope. And let me see how we're doing on time. 35. So 25 minutes left. I think we're at a really good spot here. This is going well time-wise. So now that I've kind of like talked about the deployment of the protocol, the core contracts, I'll kind of explain the non-core and the ITO, because the ITO is also phase 2, and I think it's worth kind of talking about both of these in tandem. So when we launched the protocol, really the initial, let's say, deployment of capital to the protocol is going to go through this this contract called Zivoe ITO. And the point of Zivoe ITO is to allow people to deposit to either the senior tranche or the junior tranche for a 30-day period. And I can do deposit junior, deposit senior. And there is a set amount of ZVE that is set aside for that, for this event. And so once the 30 days are up, what will happen is all the stable coins that have been deposited, of which we allow, 4 different stable coins for this particular ITO, those will all be migrated from Zivoe ITO to Zivoe DAO, because Zivoe DAO is where we house all of the capital to the system, and governance handles migrating those to lockers. So I'll come back and kind of touch on that. So all the capital will flow from the Zivoe ITO to the Zivoe DAO, and then everyone that deposited will receive their, based off the credits that they've got, the junior tranche tokens and the senior tranche tokens. So what happens is, like, if you deposit into the junior, we actually will mint the amount of the junior tranche tokens, but they stay here, and then it's not till the very end that when you claim them, that then you get your tranche tokens, your senior tranche tokens, and your ZVE as well. However, we actually create a vesting schedule for the ZVE for like a year, no clue. So that's the ITO. And then beyond that, like once the ITO is over, the only way that tranche tokens can ever be created is minting through the Zivoe tranches contract. But let me kind of come back to the Zivoe DAO here. So Zivoe DAO, and I don't know if the visualization is going to help this really at all. Well, I guess maybe I should also talk about we unlock after the ITO ends the Zivoe tranches for future tranche minting, and also the Zivoe YDL. So that has to be unlocked as well. But I'll kind of come back here. So we've got this Zivoe DAO, and you can think of Zivoe DAO as the core contract, and every other non-core contract in our system is like a locker, or visually you can think of it as like a hub and spoke model. So you've got Zivoe DAO in the middle, and then there's a whitelist, which is referenced in, really actually that whitelist is managed in Zivoe Globals here, of lockers, which the DAO can move capital to via governance and proposals. So that's where we have all of these specific lockers for specific purposes. Now, it kind of looks like, so I'll kind of go through some of the different like ways that you can transfer. So Zivoe DAO can house ERC20s, and it can push an ERC20 to a locker. It can pull ERC20s from a locker. It can pull partial amounts of ERC20s from a locker. It can push multiple ERC20s from a locker if it wants to. So if we wanted to push both like USDC and DAI to, say, a locker, we can do that. And we support, one locker destination, multiple assets, multiple amounts in an array. And you're going to notice, by the way, that there are these like bytes data fields as well. And we do this because then you can basically encode data into them, and then you can decode that on the back end and have like any additional information that you want. This data is, bytes array or just bytes is very powerful. So we can do this for ERC20s. We can actually do this for ERC721s. And we also implemented support for ERC1155s if it comes to that. Perhaps, we'll see. So again, Zivoe DAO is like that primary contract where all the capital is housed, and then assuming a locker is whitelisted, because we would want to go through an audit process on those lockers, but any locker could be added down the line, which goes back to that one person's question about, can you have additional underwriters in the future? So we can make a new locker called OCC modular. This handles lending. I'll explain what these terms mean here. And it could have a new underwriter, and we can deploy it, and we can specify a new underwriter for this particular locker because it's immutable. And then we can migrate capital from the DAO to that locker for that lending. So the different types of lockers that we have, and then I saw there was another question. I'll come back to it. We've kind of come up with this OCC and then another letter there to describe the different sets of lockers that we've categorized. So OCC is on-chain credit. This is for lending. This is primarily what the whole protocol is for. We have on-chain emissions, which actually allows for ZVE to be pushed here from the DAO. And then we can, basically it decays exponentially, mathematically speaking, and then anyone can call this function over time called forward emissions, and it pushes it to all of the staking contracts. So we can actually allow for like additional staking rewards in ZVE based off of these emissions. And that just reminded me, I do need to give a breakdown of Zivoe rewards vesting, and Zivoe YDL. So I'm going to come back to that after I just describe the categories, because I don't need to go into much detail about these contracts. But OCG is not in scope. OCG was just on-chain generic that we used for testing. OCL is on-chain liquidity. So you can push from the DAO like USDC and ZVE, and it'll automatically set up for like Sushi or Uniswap a pool, or it'll add liquidity or take liquidity or manage that. On-chain redemptions, this is actually, I think, out of scope as well. We're not going to launch with this, so I won't go into that. On-chain treasury for the DAO, YDL, ZVL. So this is just for converting, say we have assets we need to convert from like one stablecoin to another, or say we get rewards in a protocol from like Curve or Convex, but we need to convert that to like one type of stablecoin. We can use these on-chain treasuries, send it to it, and then it can be via a keeper, converted from that asset to the asset that we want, and it forwards it. So convert and forward it to the destination. So anything that's converted here, it can't be taken out. It can't go anywhere. It has to go to the YDL, for example, here. Or it has to go to the DAO here. Or it has to go to ZVL here. So these are just kind of guardrails we've put in place. And this is where that 1-inch V5 integration and the Zivoe Swapper integration kind of comes into place. OCY, this is a great category. It's my favorite. On-chain yield. So if we want to deploy stablecoins from a protocol to like convex pools, we can do that. Or OUSD, like other protocols for yield opportunities, we can just do that. And this handles all the mathematics from like, here's our basis for how much we put in, and here's how much we've made, and that's the yield, and that should go back to the DAO, or that should flow to the YDL because that's yield and profit. So it's a breakdown of the different categories that we've gotten. I think the README on our Zivoe core Foundry repository also kind of gives a breakdown at a high level of what each of these are as well: on-chain credit, exponential, generic, liquidity, redemptions, treasury, and yield. And the Zivoe swapper is utility because this is used in a couple of them, but primarily for the on-chain treasuries. Okay, let's see what questions we've got here. Is Zivoe Underwriter multisig available? As the multisig will be interacting with these contracts, wondering how the underwriter transactions are initiated, if there are any checks on call vals. It will be a multisig with Gnosis Safe that will be created prior to deployment. It is not created currently. Or can the multisig send any call vals, and the contracts in the audit are the only checks on the values? The multisig should be able to interact with the endpoints in any way. Any input parameters should be assumed to be allowed or valid, if not otherwise checked by require statements. I think we have actually implemented some require statements on the bounds of, say, for our OCC contract here, to just check those upper and lower. Like, for example, if we're creating an offer, we have like, term has to be greater than 0, which is the duration of the loan, how many payment intervals, like how many months or quarters. Payment interval has to be a set between these 5. Grace periods greater than or equal to 7 days. Payment schedule, like, so we have bounds on some of the inputs to these, and these should be assumed to be valid bounds, unless they would otherwise cause some critical error that we haven't identified. All right. So I think, just looking at time here, we got about 12 minutes left. I think what I want to do is just spend this time just explaining a couple of the contracts still remaining in the system at a fairly, I'm going to dive into a little bit of detail because, 1, they're cool, but 2, I think it's important to know, just what these contracts, how they're intended to function. I'll start with the core contracts. Those are most important. If I have time, I'm going to go into some of the lockers. So I've already given a kind of a brief overview of Zivoe DAO. Zivoe Globals is pretty straightforward, just houses information. The iskeeper, yeah, so there's a defaults. So if there are defaults in the system, like say there's a default on a loan from the OCC contract, that can be affected, that will affect this Zivoe Globals contract, and it will affect this defaults value here. And it kind of looks something like this, because in Zivoe Globals, we've got an endpoint called increase and decrease defaults. And these can only be called by is lockers. So when we say that, hey, a locker, which is responsible for doing loans, it's a locker in it, and there's a default, then it has the ability to refer back to Zivoe Globals and increase or decrease defaults. So you can say increase defaults. Well, how would this occur in OCC modular? Well, if the smart default endpoint is called, and whatever the principal owed left on that loan is standardized, of course. I should talk about this. I'm going to talk about this here next. Then that would go ahead and it would increase or decrease defaults in this Zivoe Globals, because there's also a way to decrease defaults as well when payments are made to resolve a default in the system. So defaults can increase, but they can also decrease as well. There's two more things I need to talk about. One is when it comes to standardization of decimals in the system, imagine you've got a USDC loan for $1 million and you've got a DAI loan for $1 million. On chain, those are two different amounts, all things considered, because USDC uses 6 decimals and DAI uses 18 decimals. So if we just took the raw values of them and then just updated like these defaults, it wouldn't be correct. So you're going to see this standardized function used in a lot of places, which is you pass in the amount, the raw amount that you're working with, and the asset that you're working with, and you get back a standardized amount, standardized to 18 decimals. And what that does is it uses the IERC20 metadata interface to check the decimals supplied for a given contract. And it can handle anything less than 6. It can even handle anything more than 18. It can handle anything less than 18. It can handle more than 18. If we've got something that's in Ray, R-A-Y, which is 10 to the 27th, for whatever reason tokens start being used in that precision, we can handle that. And it'll decrease the precision, truncate it a little bit, or it'll increase the precision if it's like 6. So it'll add 12 zeros to it. So this is a standardized, a very important function here. Now let me go back to defaults here. Defaults is very interesting because this actually has something that it affects this endpoint called adjusted supplies. So adjusted supplies, you can think about supplies, there's 2 tranche tokens. And this is a great segue to the Zivoe YDL contract. This Zivoe YDL contract is responsible for distributing all of the yield to the system. And we've got these like target yields for the different tranches. We have like a senior tranche and a junior tranche, and we can have a target yield for the senior here. Target annualized yield is 10%. And we have a ratio of that from the junior to the senior, which in bips, this is representing 220%. So if we have a 10% yield here, 220% of that is 22%. So we have a effective ratio, which is then our junior tranche target yield is 22%. But what does that mean? If you have a 10% yield target on the senior and a 22% yield target on the junior, what does that mean? Well, that actually means that it's a target yield of the size of the tranche. Okay, so we need to track the size of the tranches. But if there are defaults in the system, and this is a rabbit hole before I even explain what the YDL is, but I do need to point this out. If there are defaults in the system, that actually suppresses the size of the tranches. And this is how the junior tranche protects the senior tranche. Because if there's defaults, we don't say that the size of the senior tranche goes down and it should be getting less yield. We say, hey, no, we need to take that from the junior first and decrease the junior tranche. So that's how the protection and the junior tranche is implemented to protect the seniors and give them, they get a lower yield, but they have lower risk. Juniors get a higher yield, but they have higher risk. So Zivoe YDL is very interesting. Let me stop there just to see if there's any questions. All right, this is perfect. So Zivoe YDL, what we do is all the yield in the system flows to the YDL and it's held there. And then every 30 days, we have this function called distribute yield that can be called. And we timestamp this, so only every 30 days you can only call it. And then you can't call it for another 30 days. And we have some EMA-based, so we actually track the size of the tranches on an EMA system, so it's actually lagging if you're familiar with what an exponential moving average is. You can kind of think that what this YDL is doing, say we've got like the Dogecoin and we've got the daily value. Imagine this was like the size of our tranche token, the size of our senior tranche. Well, if you add an EMA indicator to it, which I want to add an EMA indicator. What we're actually doing from a mathematics standpoint is saying, hey, actually, the size of our tranches should be based on an EMA. So look at this blue line. So that's actually how we denote and denominate the size of the tranches. So it's more smoothed out, and like if things are just going crazy, we have a little bit of lag time. Technically, we have like 14 days, but anyways, so that's actually what we're doing here when we have these two EMA values. And then what we do in distribute yield is we have a water flow to distribute what's in there. And we start with the protocol earnings, and we distribute those. And then we do the senior and the junior tranche next. And then we have the residual earnings. So the way this works is, say we have $1 million in the contract, and our protocol earnings rate is 20%. Well, what we do is I'm going to go down here because this kind of shows what we do to begin with. So we have an array of people that we give the protocol earnings to, and it's straightforward what you do for the senior and junior. And then we have an array of people for the residual earnings. So the protocol earnings is the first that comes off. So out of that $1 million, let's say it's 20%, that's 200K. And then that goes between these two destinations here. This can actually be adjusted by governance, by the way. This is just what we have initially. So 66.66% goes to the ZVE contracts. The other 33 goes to ZVL. And then for the junior tranche and the senior tranche, what we do from there is we, based on the EMA values, we pay this much to the senior tranche and this much to the junior tranche. Then if there's anything beyond that, we call that residual, and we would give any extra from there. So if we had like 100K left, 66 would go to the, again, and the other 33 would go there. The math for all these calculations, like for what's happening, is under Zivoe math. So EMA calculations, junior proportion, senior proportion. I mean, this is fairly intricate mathematics, and I think it's fair to assume these calculations are structured appropriately. But I'm happy to take explanations or even create additional resources or information regarding how these equations operate, their derivations. I think we're supposed to have on our docs a page for how these came about. Mathematics. So these actually describe the purpose of these mathematical endpoints and the derivation, what each of the equations means. It gives a breakdown of examples. It's got some beautiful latex here. So this is what you would want to refer to yield distribution mathematics when you're talking about Zivoe math and how everything's happening in the YDL. So I think that's a really good breakdown. And I'm just going to briefly describe, I got 1 minute, take a shot here at Zivoe rewards and Zivoe rewards vesting.
Again, just a second, sorry to interrupt.
Yeah.
Since you have a lot of people watching, if you have the time, we can take an extra 15-20 minutes if you feel there's stuff that's worth going on, covering. So please feel free to take that extra time. Okay. And give as much value as you can to our WhatsApps.
Yeah, thanks, Fortune. I don't think I'll need too much more time here, but I will kind of go through these last contracts, and maybe I'll dive into one locker. So let's just kind of assume I'll take an extra 15 minutes here. So Zivoe rewards and Zivoe rewards vesting, these were initially forked from the Curve multi-rewards contracts, although they have certainly been modified a fair amount. So yeah, and I don't know where I could find it, but if you, it's from the Curve protocol. So the point of these, and I think they're really cool, is to allow you to stake a particular token. We do 3 of these: one for ZVE, one for Zivoe Junior Tranche Token, and one for Zivoe Senior Tranche Token. The point of these is to stake your token and then think about the YDL distributions. So the YDL says, hey, we've got this yield that we need to distribute, and it does this every 30 days. It comes into this contract. And what this is intended to do is to actually distribute that yield that came in linearly over a 30-day period for multiple assets. So if you kind of remember, in our utility contract, we set up everything and we had different rewards. So we have DAI and ZVE. So it can do this for multiple rewards, theoretically an infinite, but we actually capped it at about 7 just because we were concerned about if you could just add 100 tokens in there and the math to handle that, leading to some overflow. But that aside, there's a stake for helper function for future things here, but pretty much a lot of this, just at a high level, is just, anybody can call this deposit reward function, and that adds more yield here that will get deposited over the next 30 days, and it kind of handles it sequentially. Like this yield is for this 30 days, this yield is for this 30 days, this yield is for this 30 days. And it handles mathematically updating, kind of like if you think of a slope of how much it should be giving out over the next amount of period, it handles that. And this is all just the mathematics for it. And this update reward modifier is very interesting because anytime anything is ever done, it calls that update reward modifier to trigger and update sort of the mathematics of the system. And so you can withdraw. Vesting is just a little bit more interesting. Let me explain vesting and how that kind of is differentiated, but then why these rewards contracts are really critical within the operation of the system. So say we're vesting out ZVE for team members, investors, future team members, future investors, whoever else, partners. You start a schedule, there's a start, there's a cliff, and the cliff just basically means, like, say it's a 4-year vesting schedule with a 1-year cliff. You can think of it as like, okay, you can take these tokens out after 1 year, 25% of them will unlock, and then every second beyond that, more and more will unlock. So you have like a linear vesting schedule within a staking contract that linearly vests the yield that's received. And ZVL is responsible for kind of creating these vesting schedules and, revoking them if need be, but that's only if revocable is allowed, which presumably wouldn't for many. And yeah, then to withdraw it for the people that are vesting, then you can just kind of, it checks your vesting schedule and how much you've withdrawn in total and how much you should reasonably be able to withdraw. The important thing, though, about Zivoe Rewards vesting and the ZVE contracts for Zivoe Rewards is that in our libraries folder here, we have made modifications such that Zivoe token is an ERC20 votes through Zivoe votes. Actually, wait a second. Oh, I know. And then in our governor contract, Zivoe Governor V2, we have something called get votes _ get votes. And what this does is it looks at the Zivoe Rewards vesting and the Zivoe Rewards get pass votes. And so that would mean that these are the these are the Zivoe votes contracts. So Zivoe rewards is Zivoe votes, as well as Zivoe rewards vesting is Zivoe votes. And the purpose of this is very important. It's that if you are staked or if you're vesting, you can actually participate in governance proposals, and it tracks how much you have when the proposal is created. So it actually tracks a specific block number. So that's the purpose of that. And in order to, and actually in order to accomplish that, we actually changed a couple things in Zivoe in the base implementation of the Open Zeppelin GTC and TLC, and we also did this for another reason as well, which I'll explain why there's these large copy contracts over here. But it is very powerful for the protocol. And sorry, I'm getting a frog in my throat. To be able to do this. Also, this is important if you're vesting, because then you can actually get yield from the system that you otherwise wouldn't, even though you're vesting. So that's another important aspect. Let me just check real quick here. All right, so we got about less than 10 more minutes. Where's the price data oracle coming from? We do not use price oracles for anything. We just assume, by the way, on a one-to-one basis, like when you put one stablecoin in, that's, a one-to-one, and you get one tranche token out. And that's kind of an assumption in the system, which, certainly could lead to arbitrage opportunities if there were, minute kind of volatilities, give or take 0.5% in stablecoin pegs, for sure, one way or the other. So one of the other things we did too, by the way, that I want to talk about, Zivoe GTC, Zivoe TLC. These are huge contracts. And by the way, I should have came out the gate saying this, and I really want to make this clear to everyone. And I'll answer this here in a second. Please do not audit the majority of Zivoe GTC and Zivoe TLC. Please do not do that. Like 99.9% of the code in these contracts are literally from Open Zeppelin, and it should be assumed that they're valid, they're safe. I mean, it's very large lines of code here, but this is not something that we would expect people to spend time on, nor should they. Because what we did, there were private endpoints that we had to overwrite in order to accomplish a certain thing. And that was basically when, I think it's in the TLC here, we have this is operation ready keeper. And pretty much what we've done is, say there's a proposal that's going to go through, and it passed and it can be executed in 24 hours. But say it's a proposal that's going to move something into a yield locker, or it's going to move the markets in some way. We need to protect ourselves. We need to mitigate the MEV exploits on these fronts. And so what we've done is added the ability for a keeper to, at its discretion, 12 hours in advance, a proposal that's already succeeded, it can execute it at its discretion. And this creates randomness. This can then be executed through a Flashbots RPC URL, so no one knows when it's going to happen, to basically hide a transaction before it occurs. And because we couldn't update a private endpoint in the Open Zeppelin repository, we had to literally copy their whole code into here and then just change it from a private to a internal modifier. Kind of sucks, but that's the functionality we needed, and that's what we had to do. Kind of also inflated our lines of code a lot, but that's okay. But seriously, do not go through all of these. I mean, just look at anything that has like the word keeper in it, because that's really just Control F and keeper, and you can see here it just allows a keeper to just basically execute a transaction or execute a batch of transactions at a time, and it checks the before and the after call. I mean, that's pretty much it. I don't even know if we did anything special here in Zivoe GTC. I think we might have just needed to, we just needed to do this just to be able to set things up. There might be something in Zivoe GTC. I'll check on that. So that's the final note there. I think I've pretty much covered just about everything. I mean, I feel like there's great documentation, kind of going back to this Figma for what actors in the system are allowed to access which endpoints. We've got governance being ZVE, we've got ZVL being the kind of an administrator of the system. Lockers this is kind of interesting, but they have access to the Zivoe Global's endpoint. Governance, this is great here to just kind of get a really quick rundown about what can governance do, what is governance capable of changing. All is just anyone, include anyone and everyone under the sun. So this is for all the core contracts over here, and then this is kind of, we separated this for all the lockers over here. There's underwriters, borrowers, I suppose borrowers and lockers, underwriters and keepers. I kind of given you an explanation of keepers. I mean, keepers is a whitelist, just like lockers are whitelisted, managed by ZVL. They aren't intended to have really access to, it's intended to be internal. I guess initially keepers are intended to be internal, just kind of capital managers for just keeping things flowing, converting assets, or keeping things protected from MEV exploits. So OCR modular is not in scope for right now. So yeah, this Zivoe visualization, this Figma is great. As I understand, we have a Discord channel set up in the Sherlock Discord server, which I will be monitoring. Feel free to, maybe even feel free to if you got a question, do at Johnny Q, so I can get a ping on my phone and see it and respond. But I will be checking it throughout the audit periodically to answer any further questions you guys have. And I think that is a wrap on this code walkthrough.
Awesome.
Sorry, correct. Yeah, even users who have their ZVE stake can participate in voting. That's what we wanted. So you can get the yield and you can participate in governance. It's very important. Okay, yeah. Thanks.
That's a wrap.
That's a wrap.
Awesome. Thank you, John. Great walkthrough. Great explanations. Artemi, anything else you want to add before we shut off the live stream?
I think we're coming to the end. So thank you very much, John. Yeah, so that has been incredibly helpful, and I think all the Watsons would say thank you to you for this code walkthrough. So we're coming up to our Q&A session. So if you have any questions left, you feel free to ask them in the chat. And I think, by the way, we have more than 300 viewers watching us live, so that's great. Yeah. And yeah, guys, if you have any questions, you can ask it here and John will answer them now. Or as John mentioned, we have a channel in our Discord and you can ask also during the contest any questions there. Yeah, and I think let's wait a bit for the questions in the chat. And yeah, after that, we'll go to the end.
Cool.
Don't be shy. Ask some questions. While I check on Doge price again. Actually, a huge rip in the markets today. How about that?
Yeah, we shill the Dogecoin a bit.
Oh yeah, this is not financial advice. Do not buy Dogecoin.
Always important to say. Oh, looks like we have a question.
When a loan defaults and is recovered off-chain, is this money later funneled on-chain to pay off the defaulted loan? Yes. While I am not the attorneys involved, we will have lots of legal agreements written with the borrowers, and there are flows to make this happen. The particular endpoint that this occurs through in the OCC contract is, conveniently have it pulled up right here, resolve default. The idea of the loan, the amount to be resolved, and maybe it's only partial, or if it's the full amount, then it becomes fully resolved. So that is, and then it decreases defaults from there and transfers it back to the DAO. Oh, one interesting thing too about OCC contracts is now that I just thought about it. We have a differentiation between principal repayments and interest repayments. And principal repayments, we look at that as kind of capital that should remain in the system. And interest repayments are capital that is profit that should go into the yield distribution locker, the YDL. So you'll notice here, like on kind of any kind of payments to these loans, like the interest goes to the, any late fees goes to the YDL, and then everything else will go to the owner of these lockers are always going to be the DAO. Or if for some reason, and just to show you, like if for some reason, the YDL needs to be a specific stable coin. If for some reason it's not, then it goes to the OCT YDL. Like say the YDL is in DAI and this is a USDC loan, then that is forwarded. That USDC is forwarded to this YDL treasury here, and then that keeper would manage converting that USDC to DAI and then forwarding that to the YDL. So that's how we get around these. Like, I mean, we want to be a multi-stable coin capable protocol because that's like ridiculously important, and that's how we handle that. Yes, X audit. You must ask a question. I recover and lost junior trust funds. Yeah. So yes, you can certainly recover and pay off the junior tranche. It's intended to be done that way from a legal from an on-chain perspective and a off-chain perspective as well.
Yep. Okay, then I think we don't have any more questions for now. Thanks, John, for the brilliant explanation. And that's all for today. Thanks, everyone, for joining us today. And good luck to all Watsons with the Zivoe contest. Thanks, John.
Okay. Thank you, Artemi. Thank you, Forja. Good luck to all the auditors out there.
Okay, everyone.
I encourage critical thinking and exploration and observation. All right.
Sounds great.
Cool.
Thank you, guys.